Hello guys, in this video we are going to see about a Python framework which is widely used among the software testing lifecycle. There were few videos in recent times, but I'll try to be more consistent in posting the content. With that said, welcome to our channel 0 Watts. Do you know that software validation values about 30 to 40% of total project cost? And engineers do a lot of regression testing to find bugs in their software. Today we will explore about a Python framework which had proven its capability on the automated validation conditions. Without further more delay, we shall go into the video. The framework we are going to see today is called Pytest. Google it up and the official documentation page will look like this. I would say the documentation is done pretty well for beginners, and for the advanced topics, well, we'll get to that later. I already have Pytest installed in my PC, so a Pytest version gives the current installed version. You can easily install it from either pip or kunda with the command like pip install Pytest. Since I already have it, for me it shows like requirement already satisfied, and in your case if it is not installed it will show some installation progress there. Okay, so let's fast forward a bit. I'll create an empty directory and a Python file so that we can explore this Pytest. Inside that file I'll import the Pytest, and I'm going to create a dummy function that takes two parameters x and y. So we'll just do a simple addition with these two parameters and we will return the sum of that. Now that we have a function called addition, let's say we want to validate using Pytest, maybe like passing a different integer or even string. So for this we have to create a test function. So I'll call it as test underscore addition. So the naming convention should have the test keyword, so either in the prefix or suffix. So I'll call this assert keyword and a function called the addition. I will pass some parameters, let's say 5 and 6, and I will give some expected value. So what actually happens is from line number 8, the function is called with two arguments 5 and 6, and it checks whether the return is equal to 11. So we'll run this test case. To run, we need to use pytest command, and since we are in this directory itself, we will directly mention the test case, test file name, and with the colon, we will choose the particular test case. So this will be like useful when you have multiple test cases and you need to run a particular one. So you can see like it collected one item and it passed, and it prints few more information like versions of software that is currently being used. So let's modify this expected value and see like what is the behavior. On execution, you can see that the test failed represented in red, and also it says the reason and where or like which line from the code the failure is raised. Remember this, for Pytest to capture your test case or test file, the naming should have test either in prefix or in suffix place. Now that we have created a test case and seen how to run a test case by invoking the pytest command, we will move to the pytest internals. The first thing we are going to see is called pytest fixtures. These are nothing but another functions, but it is decorated with the syntax pytest.fixture. For example, in our case, let's say I wanted to print some debug statement before and after the execution of our test function call. So let's see how this can be done using pytest fixtures. I will name the fixture as debugger, and let's have a print statement like start of execution. So this will be printed like before the test case is executed, and once the execution is completed, let's say I want one more print statement like end of execution there. Now we have two debug statements. One should be printed before the start of execution, and one statement should print after the test case has completed execution. So to switch this control between our fixture and test case, so I'll use generators here. So it goes by this keyword yield. Also notice that the fixture name has been added as an argument to our test function. So let's run the test case now. I will mention the test file itself, the test sample.py, and we can see like the test case again failed because of our assertion value, and we have multiple print statements. So we'll come from the start. So the test case has failed and it failed at this particular point of code, and we have something called std setup, which is before the start of the test case, and we have the print whatever we have included in the fixture, and it goes to the text execution, execute the test case, and after that we have the teardown. Like teardown is like after the test case has completed running, so we have that print statement there. So maybe like we will try to understand more with one more print statement inside our test case itself. So I'll just add a dummy print here, and let's run the test case again. I will clear the window first, and we will run the test case again. Now take a look at these print statements. So we have std out call, which is the test execution part. Whatever debug statement we have there, it will come at this part of debugging there. From the execution point of view, the test case got collected, and since the fixture was there, it went to the fixture control, and there it printed the first debug statement, and it encountered the yield, which means it returned the control to our test case, and we see inside test execution print. And after that, we are doing an assert, and the assertion failed. And after that, the complete execution has been done. It returned the control again back to our fixture, where we printed the end of test session debug statement. What we have seen now is just an example to understand the fixture flow. In real time, like fixtures are used for multiple things. So one such example is a setup and teardown process. So setup and teardown, in sense, it means to prefetch the data which are needed for our test case execution. And also once our execution is done, we need to release the resources that are being used there in our test case. So let's say like now we have to open a database and do some query on the database and see whether the value is there or not. So we can use a fixture in such a way like the opening of database can be handled in our setup process, and the query can be handled inside our test case, and once everything is done, we can pass the things to our teardown, like the same fixture, to close the connection with the DB. So that's all about the content for this video. I hope things that we covered made sense and helpful for you in some way. We will explore more about the Pytest in our upcoming videos. So if you find this useful, please do like, share and comment. And please feel to reach me if you have any doubts in this Pytest. So I'd be glad to help you guys. So thanks for watching and take care.